This is section 532. We're going to look at the rational zeros theorem. So we're going to find the possible rational zeros of a polynomial. Now, the rational zeros theorem, the reason why we need this is because if we examine a polynomial like this, it's not factored, and I wanted to find the zeros, well, we know that we have to divide to be able to factor it, right? That's why we practice polynomial division. But what values do I start with? Do I start with 1, 2, -1, -2, 1/2? Like, there's technically an infinite possibilities, and so this theorem takes those infinite possibilities and says, here's a list of these possible zeros. So what the theorem says is if you have any polynomial and your degree has to be greater than or equal to 1, and these numbers in front of our polynomial are integers, right? So we're saying that it's a polynomial. We're going to get a list of rational zeros if I take the factors of the constant term and divide it by the factors of the leading coefficient. And it's every single one of those possibilities. So if I do every single one of those possibilities, it's going to help us. So list all the possible zeros for this. So it's saying we have a list of p's over q's. So you take all the factors of our constant, which is 1 and 3, over the factors of our leading coefficient, which is 1 and 2. So you do every combination of the number on top over the number on the bottom. So 1 over 1, 1 over 2, 3 over 1, 3 over 2. And then each one of these is plus or minus. So now instead of an infinite number of possibilities, it's only these 8 possibilities. And then I could test it. I can say, is 1 is 0? And I can go through and divide it. Is -1 is 0? And I can go through and divide it. Is 1/2 is 0? And I can go through and divide it, etc., etc. Let's look at the next one. We need to find our p's over q's. So p over q, factors of our constant. So factors of 10 over the factors of our constant, which is 1 and 17. So you do every single one of those combinations. So 1 over 1, 2 over 1, 5 over 1, 10 over 1, and then 1 over 17, 2 over 17, 5 over 17, and 10 over 17. And then each of these get a plus or minus. And these are my possible zeros, and so we would use polynomial division to test them out. I want you to try this one. Find the possible rational zeros. Okay, so this is our list. Now I just wanted to point out, you might be wondering, like, wait a minute, what about 10 over 5 or 20 over 5? Well, 10 over 5 is 2. Well, that's a repeat. I already have 2 there. 20 over 5 is 4. I already have a repeat. You don't need to list repeats. So this will be a list of my possible zeros. So what did we learn today? We learned the rational zeros theorem. And what the rational zeros theorem says is you take the factors of the constant over the factors, the leading coefficient, we call that our p's over q's, and you create a list plus or minus them, and that's going to be a list of our possible zeros for testing to see if we can divide our polynomial. This does conclude our lesson. If you have any other questions, please leave them in the comments.